Good morning, everyone. I'm Mario Bourgoin, the Partner Global Tech Lead for MLOps. Today, we'll look at why you want to have MLOps for your machine learning practice. Gartner research shows that only 53% of projects make it from AI prototypes to production. This is terrible. CIOs and IT leaders find it hard to scale AI projects because they lack the tools to create and manage a production-grade AI pipeline. The road to to AI production means turning to AI engineering and ML ops, a discipline focused on the governance and lifecycle management of a wide range of operationalized ML and decision models. ML ops stands on three core pillars: data operations, model operations, and the usual DevOps. A robust MLOps strategy will facilitate the performance, scalability, interpretability, and reliability of machine learning models while delivering the full value of AI investments. Machine learning is different from other software development efforts. And yes, I see machine learning as a software development effort because with machine learning, the data writes the code. So you need to have a lot of relevant and clean data for your code. And you need to have a stream of incoming data for inference. And you need to monitor that data to look for changes for retraining. Another difference with machine learning is that the code is expected to make decisions. So you need to be able to explain those decisions, which means you need to implement responsible AI. This is where machine learning operations, or MLOps, step in. With MLOps, you implement a reliable, repeatable, and robust path from use case to solution. This is recommended for even a single model, but required for running ML at scale. What's the value of MLOps for your AI practice? MLOps reduces the time to market by using an automated ML workflow. MLOps improves the quality of your ML models through consistency and quality checks. MLOps delivers operational excellence through a reliable and traceable, transparent process. And MLOps traceability and explainability automates ML governance. MLOps combines the capabilities of machine learning, data engineering, and CICD practices. So the data engineering side here is the data operations we were talking about before. Machine learning, I assume you're familiar with. And DevOps is, of course, the typical practice for the packaging and deployment of software, which is applied to machine learning models. Machine learning is at the nexus of practices that recognizes the importance of people implementing processes using technologies. So MLOps practices recognizes the different roles that people take on, the different processes that come in, including data preparation, model training, model deployment, model monitoring, and model retraining, and the technology that underlies this. These days, a lot of this work gets done in the cloud, although there are still cases where people do their work on laptop, on-prem, or particularly in a hybrid environment. When we look at the stages of adoption of AI/ML and ML ops, typically we see first a customer completes their first proof of concept and sends a model running into production. They likely have many of the base practices taken care of in terms of the services they're going to use, the service approval, understanding how to deploy ML models and integrate them into the systems that are going to consume them, as well as some basic understanding of how to manage ML models in production. When a customer has or will have multiple models running in production, there comes a need to increase the level of automation to ensure the deployments are repeatable by adopting base MLOps practices. This typically means creating and managing multiple disparate end-to-end pipelines for data, deployment, and retraining. Automation is great, but it's just as easy to automate and quickly deploy low-quality software as it is to deploy low-quality models. So you have to implement quality gates and advanced monitoring and logging capabilities to ensure you're able to reliably deploy and manage your workloads as the number of models increases. It's also key at this stage to ensure that your models actually produce the business value that you were expecting to get. As you begin to increase the number of automated quality gates, as well as adopt MLOps practices such as continuous integration and continuous delivery, we move into a stage where we're able to scale across many ML workloads. When we look at the stages, there are practices within each of these adoption stages which really align to the increased adoption of MLOps practices to move from a project or repeatable stage to adopting ML workloads at scale. Going from initial to scalable really requires focusing on the practices that enable MLOps. Here are metrics to evaluate how far you are along the stages of adoption. First, do you have a manageable time to create a proof of concept? So that goes from you have identified the business problem you're trying to solve, you've identified the data, you've trained the model, you've made sure that it solves the problem you're trying to solve, and you're trying to see how well you can deploy it into production. Are you able to deploy your models to production in a repeatable timeframe? Once you have a number of models, you're going to want to be able to do your training and deploy these models to production in a way that you can count on, so that when you need to update those models, when you need to bring in a new model for a particular practice, then you're able to do it in a repeatable way. Do your models perform as expected in production? That's going to involve being able to monitor your models in production, to be able to take a look at the outcome that you get from using your model's predictions. And you're going to be able to decide whether or not things have changed in the world to need to create new models. Finally, this comes up to the question of, are you refreshing your deployed models within acceptable time? So once you have models deployed, you're going to see that the world changes, your models change, the economy increases, the Fed comes in and increases interest rates. Don't tell anybody I said that. And then suddenly the model that you had doesn't work or produce the business value you wanted it to have. So you need to retrain your model with fresh data to bring your model up to date with the current conditions in the world. If any of you are familiar with the evolution of DevOps practices and the maturity models that resulted, this grid of people, processes, and technologies in the various stages may look familiar, but we've tailored this towards MLOps practices as customers go from the initial POC or project-based stages to being able to scale the development, deployment, and management of ML workloads. There's a lot in this particular slide, And it doesn't really make a lot of sense for me to go through each of these, but we're going to be making these slides available after this so you can take a look at this information on your own time. Um, we, there's a lot that's present here, but we do plan to have deep dives and further field enablement across the board. So for now, let's turn to the technical perspective for MLOps and AWS. So service tool selection, creating a consistent path for the production of models, integration with existing tooling, integration with client applications, and ongoing management and operations. Um, thank you. I think I went faster here than what I had expected to. So I think I am ready for the next stage. Are there any questions?
Regarding the scalability part, right? How to scale a model, right? You talked about scaling earlier in previous slides. Yeah, just can you just throw some light on the scalability part?
Okay, yeah, so there are a couple of dimensions to scaling. Thank you for the question, by the way. Sridhar, you had said is your name? Sridhar?
Yeah, yeah, Sridhar, yeah.
Okay. Thank you for your question, Sridhar. There are a couple of dimensions with respect to scaling. Um, so there's the dimension of scaling the model that's deployed, scaling the inferences that you get from the model. So that's for a particular model. Then there's scaling across being able to handle multiple different models that you're going to be putting in production. So managing and monitoring those multiple different models. And then there's scaling across your organization, which is scaling to be able to work with multiple people on a problem with multiple different teams that come together and handle different parts of the machine learning process and machine learning lifecycle. Is there a particular one of these that you're interested in?
Yeah. So, I mean, any techniques are there actually? Any specific techniques are there? Scaling techniques.
Scaling techniques, yes, but is that for scaling a model inferences? Is that
Yes.
for scaling model? Yes, for model inferences, the best recommendation that I have for scaling them is to deploy onto a SageMaker endpoint. SageMaker endpoints can be set to auto scale the inferences that you make as the demands start to come in. So if you've created a model that's going to accept inferences that are going to come in from internally or through a third party or from outside of your organization, then by using an auto scaling SageMaker endpoint, then you're able to get the kinds of performance and meet your service level expectations.
All right, I got it. Thanks, Maria.
And you're welcome. Yeah. Are there other questions?
So my question is regarding that do is this MLOps is involved in some model optimization also? Like after some time the model is not performing well, so it will do some optimization, or if it just create a trigger on that, like how it happen actually this optimization?
So if I understand correctly, Mark, you're asking about model optimization in the
Yes,
MLOps process. And
yes,
so I can see a couple of places, and one of them that you mentioned was having monitored the model in practice. You see that the model doesn't deliver the business value anymore, and so you'd like to do something about that. Is that the sort of optimization you're looking to
yes,
do?
yes, yes.
Right. So when we go into model monitoring, you'll see that you need to be able to monitor the outcomes of your model to be able to take a look at the business performance, the business value that you're getting out of that. In order then to retrain your model to take into account the changing conditions that led you to have a loss of value in your model, you need to have an automated pipeline that will take care of all of the steps that you need to do in order to deploy a new model. All of these steps will go from ingesting new data into your data stores, pre-processing those data into features for model training, automating the model training part so that it automatically creates a tuned model that you can use, testing that model on held aside test data that will verify that you've actually solved the problem that you have, and then taking that model to deployment. And these days, taking a model to deployment is like taking any piece of software to deployment. It means you need to be able to do blue-green deployments or other sort of testing deployments that will tell you that the model is performing correctly in practice compared with the previous model. And then you've got your fresh model in deployment once you verify that you actually have solved the problem in production.
Okay, okay, I got it. Okay.
Thank you, Rakan.
So it can give you some trigger point that like if your model is not performing well, so it can give us some trigger point like, or it can create some trigger on that.
Yes, so there's a couple of ways of knowing that something has changed in the world. One of them is to monitor the data that comes in. So the data that you use for making prediction. And so there's a model monitor that will look at data quality and the changes in data compared to the data you use for training your model. That's one aspect. Another aspect is trying to take a look at the outcomes, which in machine learning is the labels of your model. Once you label your model, once you label your data and you train your model, when you go into practice to use that model, you're going to get data, but you won't have labels available. So at least not always. So for example, if your use case is you're trying to predict financial fraud, then if your model predicts a particular transaction is fine, you need to be able to loop back later and ensure that it was actually fraud that was predicted or not fraud that was predicted, what actually happened. And so you need to be able to bring in those labels. And at that point, there is another part of model monitoring, which which looks at your model's predictions and looks at what we call concept drift. That is, the kinds of labels that go to with the data have changed. So that part, by the way, can be difficult. It's easy if you're trying to build a recommender. If your use case is a recommender, you very quickly get the results back as to whether your recommendations have been taken. So you can pass those labels directly in to your machine learning. But as I said, it can become more difficult. So if, for example, you're looking to loan approval, you won't know that a loan has gone bad for many months. And so this can become a different sort of problem for looping back. And so what you can do to monitor your model will depend upon your use case and how quickly you can come back and say how the model actually performed.
Okay, okay. Thank you. Thanks
You're
for the
welcome, Akan.
detailed answer. Thank you. Thanks.
Um, yeah, hi. This is Arco. I'm sorry, I am
Hi,
late.
Arko.
I'm sorry I'm late, and I'm sorry if this question is out of scope. My question is for model training, if we if we are planning for an infrastructure which is the whole ML stack is running on Kubernetes with a control plane, and we have a client-side model for a use case like a recommendation engine that you're talking about. And within the Kubernetes engine deployment, let's say we have a gRPC server, which is bidirectional and is reading data from the client side, which has a, let's say, client side tensor model that is running machine learning um,
Hmm.
and sending back data to my gRPC server. Um, is there a way for me to have elastic GPU on the Kubernetes cluster, right? Like I see there is real-time data coming in. I had not prematurely expected this much data or this much pre-processing weight on my model. So is there a way that I can upscale elastic GPU rather than having to go into the cluster and reorchestrate, like changing the node pool or any of that stuff? Sorry, I
Okay.
rambled a
Well,
lot.
no, it's fine. Thank you. I'm sorry, your name was Akron?
Arco.
Arco.
Yeah,
Arco. I'm sorry. Thank you, Arco. Yes.
you're fine.
So this particular part of the MLOps presentation was focused on why MLOps. So your question is a little bit out of scope. But let me make sure that I understand and capture it so that when we go into dealing with third-party tooling or non-SageMaker tooling in a presentation this afternoon, then I can make sure to really answer to meet your needs. So if I
That would be great.
understand correctly, you're using a Kubernetes cluster for training and deploying your models. And
Hmm.
the sort of models that you've deployed are require a GPU for inferencing.
Correct.
And so your problem is that how to scale your inferencing capacity
Hmm.
based upon the demand that you have. And
Correct.
so is this the case? Right. So this is going to be this can be a tricky part in Kubernetes because Kubernetes doesn't yet have a standard way of sharing GPU infrastructure.
Correct.
And when we're going to be taking a look at this in the future, you'll look at what people do is they create pools of
Hmm.
GPU instances
Okay.
and allow particular workloads to run on those pools. And then
Let's see.
they do the typical scaling for those
Okay.
workloads that are allowed to run there.
Okay, with something like a API management tool like Customizer or something like a simple health check on the node pools, right?
A health check on the notebooks, yes.
Yes, perfect. All right. Thank you so much, Mario.
You're welcome, Marco.
Cool.
I see Asanka had a question about whether there is a standard for MLOps, like ITIL for DevOps. In machine learning in general, there was a big attempt to create standards at one point. So, for example, CRISP DM methodology that was prescriptive and would describe how the particular processes would go. Um, Unfortunately, that technique did not scale well and is not as used as it could have been to make it helpful. Um, could you tell me? I wasn't familiar, by the way, Asanka, with ITIL for DevOps. What do you get for ITIL for DevOps? All right, so I think I understand better what you're after here. There isn't at this time an organization that would provide you with uh, general certification for MLOps best practices. You can get the ML specialty training for AWS. So you can become AWS certified in machine learning. And that's one kind of certification that you get. Would that provide the sort of experiences you're looking for? There would be some look in there into best practices and how to set up automation for machine learning operations?
Yeah, thank you.